Today we look at the definite integral. So far we have been looking at the indefinite integral. Now the difference with the definite and the indefinite integral, there isn't very much. The techniques that we use in differentiation are exactly the same. The only thing is with the definite integral is we have some integral limits. Okay, so with with indefinite integration, what we have is something like this. I give you a function f of x dx. You integrate it using all those techniques that we talked about, and you end up with a function like this, g of x with some constant. Now with the definite integral, what happens is you have f of x that you're integrating, but now you also have limits over here. A and b are your limits. You're still integrating this with respect to x. And then what happens after you integrate, because you will still integrate in the normal way to get your g of x plus c, what you will do is you will now substitute your a and b into the function and then work out the difference. So you'll find g of b plus c minus g of a plus c. Okay, now when you remove the brackets, you'll see that what you have is g of b minus g of a. The c's over here will cancel because of this negative. So the definite integral between a and b of f of x, this a, b, f of x, this is just the integral, and then you substitute your a and b. So you can see it's not necessary to work out c, because c will cancel when you substitute the values and then subtract them. Okay, so all the techniques that we've used with normal integration, we will use them over here. And the only other thing we will do different from the definite integral is that we will now also substitute the values of a and b into the new function that we get. So if we look at an example, we have the integral from 1 to 3 of x squared minus 3x plus 1 dx. Now when we integrate this is a polynomial that's very easy to integrate. We just add 1 to the powers of x and then divide by that new exponent. So what we have is x squared, x cubed over 3 minus 3 x squared over 2 plus x, and we will evaluate this from 1 to 3. Okay, so what we do is we now substitute 3 over there. We will get our answer, and then we'll also substitute 1, and then we'll subtract the 2. So for the first one, we have 3x cubed over 3 minus 3 times 3 squared over 2 plus 3 minus 1 over 3 minus 2 times 1 over 2 plus 1. Okay, so this is a simple sum to do. You can work this out on your calculator and you should end up with negative 4 over 3. Okay, so that is the definite integral. Look at some of the exercises in the book. So we have exercise 13.4. This is the integral to 5 of 2x dx. Now to integrate this, we use the normal integration method where we'll add 1 to the exponent of x and then divide by that same exponent. Except this time what we will do is we'll now substitute 5 and 2 into our integral and work out the difference. So this is 2x to the power of 2 divided by 2, and we'll evaluate this from 2 to 5. So I can simplify my integral before I substitute. That is fine. So this is just x squared evaluated from 2 to 5. And it is always the upper limit minus the lower limit. So this is just equal to 5 squared minus 2 squared. Now 5 squared is 25, 2 squared is 4, so I have 25 minus 4, which is equal to 21. And this is number 3, also from your book, integral 0 to 2 of x squared plus 2x minus 1 dx. So we integrate this again in the same way. Now our integral should always be in these brackets to show that it is the definite integral. It is different from the indefinite integral. So this is x to the power of 3 divided by 3 plus 2x squared over 2 minus x. And this is evaluated from 0 to 2. Then you just substitute. You'll have 2 to the power of 3 over 3 plus this 2 will just cancel, and I'll be left with x squared. So plus 2 squared minus 2. And then when I substitute 0 over here, you can see that everything will turn to 0. So I can just write minus 1 big 0 over there. So 2 cubed divided by 3 plus 2 to the power of 3 minus 2. This is equal to 14 over 3. So that is the definite integral over there. Then number 5, the integral to, this is square root of 1 plus 3x dx. Now this one over here, we've done questions like this before. We will evaluate it using substitution. So can say let u equal to 1 plus 3x. Then this means that du is equal to 3 dx. Then you will divide by 3 on both sides, because when I look at what I have in the integral, I only have dx. I don't have a 3 dx. So I make dx the subject. So I have 1 over 3 du. This is equal to dx. Now before I integrate, I'm also going to convert these limits in terms of u, because right now they are in terms of x. These are limits on x. So when I integrate and change this integral to be in terms of u, I should also change my limits so that they're in terms of u. So the first limit is when x is equal to 1. When x is equal to 1, the formula for u is over there. So I will just substitute x into this formula there and then work out u. So this means that u is equal to 1 plus 3 times 1, which is 4. And then when x is 2, the upper limit, this means that u is equal to 1 plus 3 times 2, which is equal to 7. So I have my new limits. What I'm going to do is here, this is going to become 7, this is going to become 4, and then I have the square root of u times 1 over 3 du. Then I integrate it. Then my new definite integral is all in terms of u, and then I can do everything in one step. So when I rewrite this, the integral, my limits are 4 to 7. Then I have the square root of u, and then dx changes to a third du, so times 1 over 3 du. Okay, working this out, the 1 over 3 can go out, so I have 1 over 3, the integral from 4 to 7 of the square root of u du. So this is 1 over 3. Now when I evaluate the definite integral, the 1 over 3 can stay outside. You can multiply it in and then use it when you substitute, but it doesn't actually matter. So this becomes u to the power of 3 over 2. U to the power of 3 over 2 divided by 3 over 2, and I evaluate this from 4 to 7. Another thing you can do is you can work out the indefinite integral, and then after you get your function, then you substitute back. So in doing that, what you do is you will integrate this, substitute u, but leave out the 1 and 2. Then after you get your answer, then you can come back and substitute 2 and 1. Okay, so that is another way to do it. Either way, your answers will be exactly the same. So here, when I simplify this, what I get is 2 over 9, which can stay outside, 2 over 9. And then I have u to the power of 3 over 2. This is from 4 to 7. Okay, then I substitute this, 2 over 9. This is the square root of 7 cubed minus the square root of 4 cubed. This you do on your calculator, and you should get 2.338. That is your definite integral. So the other way I was saying is what you can do is you can also just integrate this dx, integrate it the normal way. So notice my limits are not there, so I ignore the limits for now. Then when I get the derivative, it will be 1 over 3. You do it in the same way. U is equal to 1 plus 3x du is 3 dx. This is 1 over 3 du, which is dx. So you're integrating 1 over 3 u half du. Then you get your new function. So this is 1 over 3 u to the power of 3 over 2 over 3 over 2. Okay, plus c, because this is indefinite now. And then this becomes 2 over 9. And then you unsubstitute u. This is the square root of 1 plus 3x to the power of 3 plus c. Now you apply your limits. So you have 2 over 9, the square root of 1 plus 3x cubed and our original limits were 1 to 2. Okay, so you can still do that. That is fine. You'll notice that the answers are exactly the same. Then let's look at number 7. This is also in your book. Number 7, we have the integral from 1 to 10 dx over the square root of 5x minus 1. Okay, so with this one again, we will use a substitution. So I let u equal to 5x minus 1. This means that du is equal to 5 dx. Then 1 over 5 du, this is equal to dx, because in my integral over there I only have dx, so that is what I will substitute dx with. Then again, I want to transform my limits, the 10 and 1. So I say when x is equal to 1, this means that u is equal to 5 times 1 minus 1, which is 4. And then when x is equal to 10, this means that u is equal to 5 times 10 minus 1, which is 49. Okay, so I have everything now in terms of u, so I can just do my substitution. So this is the definite integral. My limits are from 4 to 49. Then du, I will write it at the end. So this is just 1 over the square root of u. And then du, 1 over 5 du, like that. So now I've substituted everything. This is just an integral in terms of u. So the 1 over 5 can come out. My integral limits remain as they are. And I have u to the power of minus a half with respect to u. Then this is 1 over 5. And then the integral of u to the power of minus half is pretty simple. I add 1 to minus half. So I have u to the power of half divided by a half. And then evaluate this from 4 to 49. Now this half here can go out. So I have 2 over 5. And then I have the square root of u from 4 to 49. So with this one, it's easier because I don't have to unsubstitute. I just put my limits over there. So the 4 and the 49. So I have 2 over 5 multiplied by the square root of 49 minus the square root of 4. So it is always the upper limit minus the lower limit. Then doing this, square root of 49 is 7, square root of 4 is 2, so I have 7 minus 2, which is 5. So this is just 2 over 5 times 5. So those two cancel, and this is equal to 2. And then number 9, integral from 0 to 1 of e squared plus e to the power of t dt. Okay, so this one we don't need to make a substitution because it's pretty straightforward. What we do, just integrate the integral of e squared. This is just e squared times t. Remember, e squared is a constant. So when I integrate a constant, I should get t to the power of 1 divided by 1. And then the integral of e to the power of t is just e to the power of t, because the function that you need to differentiate in order to get e to the power of t is just e to the power of t itself. And you evaluate this from 0 to 1. Then we substitute. This is e squared times 1 plus e to the power of 1 minus, put it in brackets to show that you're subtracting the entire thing. This is e squared times 0 plus e to the power of 0. So here I have e squared plus e minus 1. So this is 0, and then e to the power of 0 is equal to 1. So this is the exact value, and then if you round it off to 3 decimal places, this is 9.107. Then number 11, we have the integral from 0 to pi over 3 tan theta d theta. Now integrating tan, the way we do it is by converting it to sine over cos. So I have the integral 0 pi over 3, then I have sine theta over cos theta d theta. Okay, so here we will use a substitution. Say let u equal to cos theta. So if I was integrating cot theta, I would change it to cos over sine, and then the u is the one that is in the denominator. So du, this is equal to sine theta negative d theta. And this means that negative du, this is equal to sine theta d theta. So this sine theta d theta is going to be replaced by negative du, and cos theta over there will be replaced by u. Now we just need to substitute the limits or rewrite them in terms of u. So what I have is when theta is equal to 0, this means that u is equal to cos of 0, which is equal to 1. And then when theta is equal to pi over 3, this means that u is cos pi over 3. Cos pi over 3 is just equal to a half. So this is a half. So my new integral remains or becomes this. So I am now integrating from 1 to a half, and I am integrating 1 over u times negative du. So the negative 1 can go outside, so the negative 1, this is a half 1 over u du. This is negative. I integrate 1 over u, I get ln of u. So this is ln of u. Then I have 1 and I have a half over there. Okay, so now it's just substituting. So this is negative of ln of a half minus ln of 1. This ln of 1 is equal to 0, and then negative ln of half is what we'll be left with, and this gives us positive 0.693. Okay, because ln of half is negative, then when we multiply it by this negative, we get a positive. This is to 3 decimal places. And the last one in that exercise, number 13, we have the integral from 0 to pi over 6 sine theta cos theta d theta. So here again we use the substitution method. So we let u equal to sine theta. You can let it equal to cos theta because the derivative of cos is sine, but you'll have to introduce the minus, so that's why I prefer to let u equal to sine theta, but whichever one you choose, the answer will be exactly the same. Then du, this is equal to cos theta d theta. Then I need to rewrite my limits over there. So I have u, sorry, when x is 0, this means that u is equal to sine of 0, which is 0. And then when x is equal to pi over 6, this means that u is sine pi over 6 is just a half. Now I have everything I need. I rewrite this. This is from 0 to a half. And my new integral, I substitute. Just look at it. So instead of sine theta, I write u. And then instead of cos theta d theta, I put du. So I'm just integrating mu with respect to u. Okay, so this is just u squared over 2, and then my limits is a 0 to half. So this is a half squared divided by 2 minus 0, because I have 0 squared divided by 2, that is just 0. Now a half squared is 1 over 4. 1 over 4 divided by 2 is 1 over 8, so I have 1 over 8 as my answer. So that is how to evaluate the definite integral. It's not very difficult. It is similar. All the techniques that we've done with indefinite integral, you can apply them over here. If you use substitution, you just need to remember to change your x into y. That means your upper and lower limits. Now, one of the applications of the definite integral is working out the area under a curve. So this is the area under a curve. So let's say you have a function like that, and you want to work out the area over there. This is the area that is under the curve, and this is from A to B. This is your function f of x. If your area is above the x-axis and you integrate this from A to B, f of x dx, this is just equal to the area that you are given, or the area that is shaded over there. So the application of the definite integral is working out the area under the curve. You can also use it to work out the area between two curves. So for example, I have one curve like that, f of x. Okay, my curve isn't so great. Let's say x. Let's say I have two parabolas. I have one parabola there, and then I have another parabola. This is f of x, and this is g of x. And I want to work out the area that is bounded between the two curves. Now these points here where they intersect, that is point A, and this one here is point B. Now we can work out that area. This is just the definite integral also from A to B, except this time how you work it out is not just the integral of f of x or the integral of g of x. You work out the difference. Now the difference must be the one on top minus the one at the bottom, minus that one. Okay, because that is how you would work out the area. Now when I take the definite integral, let's just look at that. When I take the definite integral, I have two parabolas like this. This is the first one. When I take the definite integral from A to B, this is from A to B. The first one when I take its definite integral, this gives me this area here. And then when I take the definite integral of this one over here, it gives me this area here. So if I want this area here, I should just subtract the two of them, because that's how we would work it out. So the definite integral of both of them just gives me the area under each of them. Then to work out the area between, I just subtract. So the way we would write this is, we look at your graph, which one is on top. We have g of x is the one in red that's on top. So I will say it's g of x minus f of x dx. Okay, so we're just subtracting areas. So you can also write this as the integral from a to b of g of x dx minus the integral of a to b of f of x dx. That is exactly the same thing. Okay, so this is area between two curves, and this is just the area that is under a curve up to the x-axis. So if it is below the x-axis, so you might have a function like this. This is a parabola. We say work out the area that is bounded by the curve and the x-axis. You can also look at this in the same way I did with your f and g, in that your x-axis is the graph that is on top, and then this one here is the graph below. So here, if you have your limits a and b, this would be negative integral from a to b of your function f of x dx. Or you can look at it as 0, and this 0 is the equation of the x-axis. So you're integrating, it's your function minus the other one. Okay, so let's look at some examples of when we work out the definite integral. When we use the definite integral to work out the area under the curve. So we have one example. We have y is equal to x cubed plus 2, and we want to work out the area between 1, x, and 4. Now if you're not sure whether your graph is above or below the x-axis, you can always sketch it. This one is a cubic function. We've done sketching them. So usually in the test, what you'll get is a question that asks you to sketch. So you use your knowledge of differentiation to sketch. You find the turning points, you classify them as your maximum and minimum, and then looking at your graph, you are then asked to work out a specific area. So because you've sketched it already, you can tell it's above the x-axis, so it's positive definite integral, or it's below the x-axis, then it is negative definite integral. Okay. So to do this one, we just integrate from 1 to 4. Now I know this is entirely above the x-axis. The reason I know that is because of the way this function is. It's x cubed plus 1. If I substitute any number here from 1 to 4 into this function, I will always get a positive value. So it means my graph is entirely above the x-axis. So working this out, I have x cubed plus 2 dx. This is x to the power of 4 over 4 plus 2 to the power of x to the power of 2 over 2, and then apply your limits from 1 to 4. Okay, so substituting here, I get 4 to the power of 4 divided by 4 plus these 2's can just cancel. I have 4 squared, and then I subtract 1 over 4 plus 1. Okay, so it's the power 4, but I don't need to write it because it's 1. And then squared, I also don't need to write it because it is 1. So this one you can just do on your calculator. 72 minus 9 over 4, and this is equal to 69.75. And because this is area that we're talking about, you should put units squared like that. Look at another example. We're asked to work out the area between y is equal to 3x and the x-axis, and we have the points x is equal to 0 to x is equal to 1. So this one we can draw a sketch, very simple to do. So this is our x and y axis. Then our line y is equal to x just looks like that, and similar to the line x is equal to y. Then we're looking for the coordinates from 0, which is at the origin, to 3 over here. Now if you look at the area under the graph, this is a triangle, and we know how to work out the area of a triangle. So we'll try it, work it out, work out the area of the triangle, half base times height, and then we'll also try it using the integration and see our answer is going to be the same. So this method of half base times height, we know that a, this is half base times height. Now of my base over here, this is 3 units, and then this distance over here, I know this line, this is y is equal to, okay, I'm labeling it wrong. So it's from 0 to 1. Okay, now it's fine. Okay, so this is 1 unit, and this line here is y is equal to 3x. So that means the y coordinate over here, this is equal to 3 times 1, because that is the value of x over there. So I get 3, and that means this side is 3. This is a right angle triangle, so my area is half base, which is 1 times 3, and this gives me 3 over 2 units squared. Then I need to work out the area using the definite integral. So the definite integral, know that the area is the integral from 0 to 1, and then I put in my formula, this is 3x dx, and then I integrate this. This is 3x squared divided by 2, is from 0 to 1. This is just 3 times 1 squared over 2 minus 0. And if you look at that, I have 3 over 2 units squared. So the two methods agree that this is actually a good way to work out the area of the part of the graph, the area between the graph and the x-axis. So let's look at some of the exercises in your book. This is exercise 13. Yeah.
In the example before the previous one.
Yes.
The one with y equal to x to the power 3 plus 2.
Yes.
Is the integration of 2 not equal to 2x?
2x. Yes, it is. I think I left that.
Okay, but you wrote 2x squared.
It should be 2. Okay, I wrote that, but my working is 2. So if you
Oh,
work it out, you will still get the same answer.
okay.
Yeah, thank you. Okay, then exercise 13.5.2. And then we have to work out the areas of different graphs. So here we have y is equal to 2x plus 1, and we want to work out the area from 0 to 3. Okay, so here again you can draw a sketch just to see what your graph looks like. Now this is a straight line that passes through point 1. Okay, y is 1, and then when x is 0, y is 1, y is 0, x is minus half, something like that. Okay, so what you want to work out is the area between 0 over here and 3, that is somewhere here. So this area is what you are looking for. Now this area is entirely above the x-axis, so you just integrate and then you put your limits from 0 to 3. So your area, this is the integral from 0 to 3, and this is 2x plus 1 dx. Also, I can just tell by looking at it, 2x plus 1, when I substitute positive values here, my answer will be positive. And then 0, it'll also be positive. So it is entirely above the x-axis. Even without the sketch, I can tell that. So this is the integral of 2x squared over 2 plus x, and then from 0 to 3. And then here we just substitute. This is, these two will cancel, and I have 3 squared plus 3, and then the other one will just be 0, because everywhere is 0. I have one big 0, and I have 3 squared plus 3. This is just equal to 12, and because this is area, this is units squared. And then 2, we have y is equal to x squared minus 3x minus 5, and we want the area x between 1 and 2. Okay, so here you can draw a sketch of this, so you know how to sketch your parabola. When you sketch it, this is what it will look like, and then 1 is somewhere here and 2 is over here. So you're looking for this area there. Now this graph is entirely below the x-axis. So when you work out the area, what you will do is you will just multiply it by, so when you work out the definite integral, what you'll do is then just multiply it by -1, which is the area. Now when you have a combination of the two, now sometimes, just to note, sometimes you could be asked to work out area like this. If this is a cubic function, if I give you this area to work out. Now if you try and work out the area without sketching it, and you just work out the definite integral from a to c, this is your f of x dx. This one over here, the definite integral, is negative because it's below the x-axis, and this one here is positive. Now if you take one straight integral, you will see that this negative takes away from this area there, and then your answer will be a smaller area than what you actually have. So that's why it's always important to sketch your graph so that you know, is it entirely above, is it entirely below, are there parts that are above or below. If it's entirely below, it doesn't actually matter because you'll see that your answer is negative. Then you know that area is not negative, so just multiply it by -1. Okay, so this one we could have just done the definite integral the way it is, but we would get a negative value. Then we know area is not negative, so we'd multiply it by -1. So we work this out, we integrate, so this is going to be negative the integral of 1 to 2, and the function we're integrating is x squared minus 3x minus 5 dx. So negative, we have x to the power of 3 over 3 minus 3x squared over 2 minus 5x, and then you evaluate this from 1 to 2. Okay, now this negative here, you can also leave it out and then switch your limits. That means the 2 goes to the bottom and the 1 goes on top. That will work as well. So substituting this, we'll have 2 cubed. So this is all negative 2 cubed over 3 minus 3 times 2 squared over 2 minus 5 times 2, and then I subtract 1 over 3 minus 3 over 2 minus 5, like that. So again, this you just do on your calculator, type this out, you will get 43 over 6 units squared. And you can also leave this to 3 decimal places, and that is fine. And then the next one, we have y is equal to cos x, and we want to work out the area between 0 and pi over 6. Now cos of x, we know how to sketch that. This is what the function looks like. So from 0 to pi over 6, that means something like that, the area over there. This is entirely above the x-axis, so I can just work out the definite integral. So this is from 0 pi over 6 cos x dx. The integral of cos x is sine x. So I have sine x evaluated from 0 to pi over 6. So this is sine pi over 6 minus sine 0. Sine pi over 6 is a half. Sine of 0 is just 0. So this is just a half units squared. Then we have y is equal to the square root of x. So we did curves like this. We say that this is the top half of a parabola that opens to the right. So this looks like this. Okay, now this graph is entirely above the x-axis. So between 0 and 2, that's just from the origin, and 2 is somewhere there. So this is the area that we are looking at. So this is simple enough. We just take the integral of square root of x dx from 0 to 2. The integral of the square root of x, this is x to the power of 3 over 2 divided by 3 over 2, and then we apply this from 0 to 2. Okay, this is 2 over 3 can go out. Then I have x cubed under my square root. This is 2 over 3, the square root of 2 cubed, minus 2 over 3, the square root of 0 cubed, which is just 0. And this will give me 1.886 units squared on my calculator. So you can try that. If I've done it correctly, then that is the correct answer. Then another one, this is x over 1 plus x squared dx. Now this graph here, you can sketch it. The difference with this graph and the other ones that we have sketched is that this is not a polynomial, but it's not very much different. Now, you don't need to sketch this one because with the limits that we are given from 2 to 3, you can tell whether your graph is above the x-axis or not. Now, my denominator is always positive, whatever the value of x is, because I have 1 plus x squared. X squared is always from 0 upwards. So whatever x is, my denominator is always positive. Now x over here will only be below the x-axis when x is less than 0. So this between 2 and 3 is positive. So my graph over here, x over 1 plus x squared, is entirely above the x-axis. So I can just take the definite integral. Now if I asked you maybe from minus 1, if I asked you to integrate this from minus 1 to 3, the same graph, this is 1 over x squared dx. Now looking at that, we do the same analysis. You can see the denominator is always positive, but the numerator will be negative from -1 to 0. So you'll have to split it and say this, you integrated from -1 to 0, x over 1 plus x squared dx. This one will be negative because this part is negative, it's below the x-axis, and then you add the area from 0 to 3 of your f of x. That's how you'd look at it. Okay, so you can see part of it is below the x-axis, so that you should look at it by itself. It's going to give you a negative value. So if you integrate from -1 to 3, you might even end up with something like area is 0, which is only possible if you are looking for the area at a single point. But if it's between two different x values, there's no way that this area can be 0. Okay, so we just integrate this one. We have 2 to 3 x over 1 plus x squared dx. So here we will use substitution. We say u is equal to 1 plus x squared du. This is equal to 2x dx. And then when x is equal to, first this is just half du. This is equal to x dx. So this x dx, I will replace it with half du. And then the 1 plus x squared, I will replace it with the u. Now it's just the limits that I need to replace. So when x is equal to 2, this means that u is equal to 1 plus 2 squared. This is 5. And then when x is equal to 3, this means that u is equal to 10. So I integrate from 5 to 10. Then I have 1 over u times half du. So integrating this one, the half can go out, 5 to 10. Then 1 over u du. The integral of 1 over u is just ln of u. So I have half ln of u, and my limits are from 5 to 10, which I will just substitute So I have half ln of 10 minus ln of 5. And this is 0.347 units squared. Okay, so we'll stop there. In the same exercise, what was it? 13.5.2, there are more questions that you can integrate. It talks about numerical integration, but we are not going to look at that. We'll only focus on working out the area using the definite integral. So there are some functions that we have not integrated. There are still some more integral techniques or integration techniques that you'll only look at in the next course. But for now, every function that we give you to differentiate, you should be able to do it using your table, substitution, or just directly integrating it like that. So there is no quotient rule or product rule that we look at with integration. Okay, so we'll stop here for today. Have a good day.
Have a good day.
Thank you.